Welcome back, everybody. So today we're going to finish our lenses chapter. We'll talk about a couple of lenses, multiple lenses, two lenses. We'll talk about magnifying glass and then microscope, telescope, briefly. Okay? And there is an example that I want to do, and I think it's an interesting one. It's nice to see things experimentally. We'll do the math and then we'll see that it works out. Okay. So here's the first example. We will have a converging lens and another converging lens. So example one. We'll have the following. Here's a convex lens. Let's call it f1. And f1 will have a 40 centimeter focal length, and then we have another convex lens f2, and we have 60 centimeter focal length, and then the distance between them is 300 centimeters. In other words, 3 meters. Okay. We're going to place our object a distance here, and that distance is going to be the distance from this lens. So this is S1, and that object distance is going to be 50 centimeters, 50 centimeters. Our object will have a height y equals to, let it be 8 centimeters. Why not? Okay. I don't think I have. Just let it be 8 centimeters. You probably know what the ultimate question is. Where is the image? The final image, right? So we need to do this in steps. What do you think the steps will be? So use lens 1 to figure out where the image of this object is going to be. Maybe here, maybe here. It might even be here. It's a virtual image. And then the image created by this lens would be the object for this second lens, right? That's the trick. So let's do that. So we need to find S1 prime. So S1 prime, we need to do this. That would be S1, F1, and then S1 minus F1, right? We did this a few times. It's 1 over S1 prime plus 1 over S prime equals to 1 over F. Move things and invert, and you will get this equation. So doing that, we need to multiply, and you will help me with this, right? So S1 times F1, S1 is 50, F1 is 40, divided by 50, minus F1, which is 40, and so this is 2,000 over 10, so 200 centimeters. Can we agree with that? So where is this object? It's 200 centimeters. So where would it be? Where is this image at? This is 300, so it would be 200 centimeters to the right of this, correct? So it would be somewhere here. It's going to be an inverted image. It's going to be an inverted image. Let's figure out its magnification. I'll put here M1 would be what? What's the magnification? What's the equation for it? Yeah, minus S1 prime over S. Yeah, over S1. And so that's minus 200, right? Over S1, which is 50. And so we get minus 4. So the magnification would be minus, so it's inverted, but 4 times as big, right? This image would be 4 times as big as this one. Sorry, my arrow doesn't, the arrow should be like this, right? It should be 4 times as big. But things are not to size, not to scale. Okay? Now, how far is this image from this lens? Because this is going to be the object for this lens. So how far are they? 300, right? I'm sorry, not 300. 100. So let's call this, let's just get a general rule. So this length here, the distance between the two lenses is 300, right? So S2 will just be L minus S1 prime, right? Which is to say 300 minus 200, right? 300 minus 200, which is 100 centimeters. So this is S2. Yes, do we agree? S2 is 100. This is maybe a complicated way of getting the same thing, but that's that. Do you have a question? I see some confusion. No? Okay. As long as that's okay. So now I need to figure out S2 prime. So S2 prime will be same procedure, right, what I did here. So it would be S2 F2 divided by S2 minus F2. So let's do that right away. So we get 100. What's F2? 60 divided by 100 over 60, minus 60. If I make a mistake, please tell me. I don't have these particular numbers. For the next problem, I do it. How much? 150? Okay. So that sounds, I think, right? Yeah, 150. Please double check, everybody. So 150? Sounds good to me. So 150, where's the 150 at? 150 from where? Positive 150, so it's to the right of this list. So 150, so this is 100, 100, so 150 would be somewhere here, right? And then let's figure out what the magnification is, M2. Magnification M2, I'll put it here. It will be minus S2 divided by minus S2 prime over S2. So minus 150 over 100. Yes? So the minus what? 1.5. Good. Minus 1.5. Let's figure out the overall magnification. You see, this one inverts it, but then this one yet inverts it again. So what's the overall image going to be? It would be upright. So it's going to be, yeah, the image is going to be upright, and it would be here, right? This is S2 prime. So the final position of the image is going to be 100 centimeters to the right of the second lens. Okay. So the total magnification is just M1 times M2, which is minus 4 times minus 1.5, and that is equal to positive 6. Yes? Positive 6. And so the height of the image, what's the height of this image? Let me call this height. The height of, this is Y. This height here, I can call it Y prime, but I'm not really interested in Y prime. I'm interested in this one, Y double prime. So Y double prime is equal to Y times the overall magnification. And that's equal to what? Y is 8, and then 8 times 6 is 48. So 48. It's going to be 48 centimeters. Okay? So that's the overall. Yeah.
Professor, why did we put a negative on the magnification of?
We got this equation a while ago.
Okay.
So magnification is always minus S prime over S. I saw another hand for this. No? I didn't. Okay. The next example is going to be the following. We're going to keep exactly the same setup, but this lens, we're going to change it to become a diverging lens. It will still be 60, it would become negative 60 centimeters. Same setup, but it would be negative 60 centimeters. So I'm going to draw it. And you should think about what changes and what doesn't change. So here is F1. It's going to still be 40 centimeters. F2, now it's going to be this diverging lens. F2 is going to be minus what? Minus 60, yeah? Minus 60 centimeters. And then their distance, the distance between them, L is going to remain 300 centimeters. Our object is still going to be here, and it will be this far. How far is that far? 50 centimeters? 50 centimeters.
Exactly the same thing as before. The only thing that changed is that length. Okay, this one I do have, I think I do have the numbers. Okay. So let's, again, what's the procedure?
Find the first image.
First image, anything that's going to change from the first image? The first image is created by the first lens, which is exactly the same, so everything here is going to be the same. So S1 prime
is going to still be 200 centimeters, and the magnification M1 is still going to remain -4, right?
magnification is still going to be -4.
And then, which means S2, what's S2 going to be?
S2,
Our image is going to be here, right? In the first one, Y prime. So this is S2. How much is S2 again?
it's still going to be 100, yeah. It's still going to be 100.
So S2 is still 100 centimeters, which means S2 prime is going to be,
We need to use the same equation, but remember the focal length now is -60.
so let's be careful with this one. I'm going to say S2 times F2 divided by S2 minus F2, which is 100 times -60 over 100 minus 60. Okay?
So that's what we need to do. Okay, I will let you figure it out and then make sure your number agrees with mine. I will tell you what my number is in a second. So I'll let you, so you need to tell me what yours is. What do we get? 1/4? Minus. Really? It should be 37 minus 37.5.
Oh, is that what you're saying? I have this, minus 37.5 centimeters.
Remember, this is minus, so it's positive 160 on the bottom. So you're saying what? 6,000 over 160, right? 6,000 over 160. So that's that. So that's the image distance. What does it mean now? Minus 37.5. Where is the image at?
Is it to the right of the lens or to the left of it? To the left of it, because this is negative. So it's going to be here. It will still be inverted. Okay, it will still be inverted. This is Y double prime.
Why? I'll tell you. Let's figure out the magnification and then see.
So what's M2? M2 is going to be minus S2 prime over S2, right? So that's minus, what is S2 prime? Yeah, 37.5, but minus. So minus minus is a plus, and then S2 is 100, yes, 100. So this becomes positive 0.375. That's the magnification, right? 0.375. So what is the overall magnification? Is going to be M1 times M2, and that's minus 4 times 0.375.
I have minus 1.5 for my magnification.
Minus 1.5.
For the total magnification. Again, those arrows they're not up to size. They're not, the size is not true. Okay, not necessarily. So overall, the image is still going to be inverted, right, compared to the object. And the image will be virtual.
And so what's the size of that object? If we really want to, we can just say y double prime is just the total magnification times the original size. Total magnification is minus 1.5. The original size is 8, right? 8 centimeters. And so this will be minus 12 centimeters. So we say the original object is still 8, right? This is 8 centimeters. Two more examples, and then the third one, and then I will show you a demonstration. Two more examples. They're going to be still the same setup. We're going to get the most out of this setup. So what we're going to change for the next one is this. This lens becomes diverging. This lens becomes converging. So it's the same as this one, but now we will change this one to become divergent. It will be minus 40. Okay? So if you like, you can start it already before while I'm drawing it. You can start it your own, and I'm going to take my time to draw it. Is 8 centimeters. Okay? Well, can we compute the same? Am I messing up something? Or I see some. Is that okay? Oh, okay. Okay. This is minus 40. Okay. So I get S1 prime would be, we would multiply, right? It would be S1 times F1, so 50 times F1, which is minus 40, divided by 50 minus 40, and we get this one. I believe I do have it. Yes, I do. I get minus 22.22 centimeters approximately. Minus 22.22 centimeters. Oh, why is it minus? It should be. Actually, yeah, minus. It's a virtual image. Yeah. Yeah. Sorry, I got confused for a moment. Yeah. So that image is gonna be where? Here, right? It would be upright. Why is it upright? You can figure out the magnification, it would be positive. But this is a diverging lens. If you put an object here, it will create a virtual image of that object, which is upright and smaller. So let's figure out the magnification. M1 is going to be what? Who can tell me? Minus what?
22.
So minus minus 22, right? 0.22 over what? 50. So it's going to be minus minus, that's a plus. I will emphasize it would be positive. If you divide by 50, you get 0.44 repeating, right? That's the magnification. So it would be like almost half the size, but it would be upright. And it would be, so that image is going to be here, okay? That image is going to be there. So this is S1 prime. So who can tell me how do I get S2? How do I get S2? The distance from here to this image. 300 plus 22.22, right? So one way, again, a systematic way to do it is this. It would be L minus S1 prime, so that is 300 minus 22.22. It's kind of overdoing it, but it's still worth it. We're really looking for this distance, right? This is what we mean by S2. Okay, that's S2. That's that total distance. So minus minus, so we got 322.22 centimeters, okay? Then we can get S2 prime. So S2 prime is going to be S2 times F2, so 322.22 minus, times F2, and F2 is 60 over 322.22 minus 60. And can someone tell me what you got? I'll tell you what I have.
73.7.
Correct. 73.7 centimeters. And that means the magnification M2. Where is 73.7? To the right of the first lens or second lens? Second, yeah, second lens. So now that's the image for this second lens. So it's going to be here, and it will be that distance is going to be somewhere here, and is going to be upright or inverted. It will be inverted, right? The reason is this lens is convex, and you feed it an upright image, it will give you here, or if it, an upright object in this case, this is the object for this lens, it will give you an inverted image, real image in this case. It will give you an inverted real image. Let's see that it's inverted actually. So we get M2 will be minus what? S2 prime over S2, right? Minus S2 prime over S2, which is 73.7 over 322.2. 73.7 over the 322.222.
0.22.
0.22 or 0.29?
23, I think. 0.228.
Okay, so 0.228, you said?
Yeah.
Okay, so I have it wrong. I have 0.29. Okay. Oh, minus. Let me make the minus with red, so it's clearly minus. Okay. So it's inverted. The first one didn't invert it, the second one inverted it, so overall you will have an inversion, right? What's the total magnification? That's equal to M1 times M2, and if you multiply them, 0.44 times 0.228, so multiply these two numbers. Is it
0.1.
0.1, yeah. Negative. 0.101. So I would just say 0.1. So I guess I have that one right. Maybe I just wrote wrong. And then you can find the final size. The final size, I guess, would be a tenth of this one, would be 0.8 centimeters minus. So let me write it. So y double prime is going to be minus 0.8 centimeters, right? I just multiplied minus 0.1 times the original size. Okay, can someone guess what the next problem is? Both diverging, yeah, good, yeah. So in the next one, we're going to just change this to be diverging. We have done about half the problem right here. All of this is going to be the same. And then the rest you will do. I'm going to draw it and then we'll go over it also. again, all this stuff doesn't change. S1 prime, magnification, and also S2. S2 is still going to be this, right? 322.2. Going to be 322.2 centimeters. So now what changes is we need to plug it in here to find S2 prime. S2 is going to be S2, which is 322.22 times F2, which is minus 60 over 322.22 minus 60. Okay, minus 50.57. You will help me, right? Make sure that that's correct. So where is the image going to be? The final image.
To the left of the second.
To the left of the second lens. How far to the left? 50 centimeters, right? So if this is 300, that's a third. It's going to be here, right? Yeah. Is it going to be upright or inverted? Why would it be inverted? Is the magnification going to be? So this one did not invert it.
Oh,
So it, yeah, it will just still be upright. And we'll see in the overall magnification. So here, M2 is going to be minus 50.57 over S2. What is S2 again? 322. So that magnification M2 is 0.157. And then the overall magnification is M1 times M2, and that's going to be the product of these 0.157 times 0.444, and that's going to be 0.07, right? Yeah, 0.07 approximately. So the final height of the image is going to be tiny, almost like 7%. What it was? Yeah, it's going to be tiny. So the final image, if you want to know y double prime, is going to be m times the original. So 0.07 times 8 centimeters. And is that 0.56? Or 0.056? 0.56, I think. Can someone tell me? That's correct? Okay. The last problem, not the last, but the last in these kind of set of problems. So the last one is we're going to demonstrate something. We're going to, luckily, in the morning I was trying to do it, but it shows lenses that I don't have in the lab. But I changed it so that we will have lenses that I have, so that we can actually demonstrate. All right? So here is the last problem. In fact, let me pause and then do it again, so it's a problem on itself.